All right, we're continuing on with 12.2, tests for independence. So given the following contingency table, conduct a test for independence at the 5% significance level. So we always start with our null and alternative. And in these cases, we would just say variable A and B are independent. We don't know anything about them, but we are trying to say if they are independent or dependent. All right, and then from there we have our observed and expected, and so we just need to get this these row columns, and I'm regretting the way that where I wrote that. So let me move it down. Okay, there we go. All right, because I need to get my totals here. Okay, so 23 plus 47 is 70, and then over here I get 85. And then that's 155, and then 23 plus 32 gives me 55, and this gives me 100. Remember, I need these to help me calculate my expected values. And I am just going to do it right into Excel this time so you can see something a little bit different. So, I'm going to do O minus E squared, O minus E squared divided by E. All right, so my observed values are, what I've got right here. And then the expected value here, okay, so the expected value for this part here comes from the row, so the row total, 70, times the column total, 55, divided by the total. And so for 47, the row total is 70 times 100 divided by 155. All right, and then for 32, it's going to be 85 times 55 divided by 155. And this one's going to be 85 times 100 divided by 155. So last time we did it by hand in the beginning, but you can also do them this way. All right, and then we can let Excel, and let's just double check every E here is greater than 5. So we'll just continue on. And then continue on here. All right, and so our test statistic is equal to the sum of this column. So our test statistic is 0.385, and our p-value, so we need to get our degrees of freedom. So our columns, we've got 2 columns and we've got 2 rows. So our degrees of freedom is 1 times 1 is 1. So we do chi-squared disk 0.3851. And we get about, our p-value is about 0.5349. And we're asking at the 5% significance level, so how does that compare to 0.05? It's greater than, so the p is low, the null must go. We're going to keep our null then because the p is high. So we're going to conclude that there's evidence to conclude that variable A and B are independent. All right, so if you want to see all that kind of written out here, there you go. We'll do one more example together, this time in a context. In general, Latinos and Caucasians use social media networks equally, but there are some differences in their preferences for specific social media sites. In particular, Instagram is more popular among Latinos or Latinx, while Pinterest is more popular among Caucasians. Kate Dawson, a junior in college, decides to test if similar differences exist among students on her campus. She collects data on 400 students cross-classified by race and social media preference, specifically Instagram and Pinterest. The results are shown in the table. At the 10% significance level, determine whether the data support racial differences. Okay, so remember, the null is independent. So our race and social media are 2 variables. Social media preference, independent, or are they dependent? Dependent. Okay, so after we get that, we need to do the expected frequencies and then our test statistic, and they give us our row totals, which is great. And I'm just gonna pop in here and just do the same thing I did last time, which is let Excel calculate those for me. All right, so my observed frequencies are just coming from that table. So when I look at the 50, when I look here, my row total is 110 times my column total divided by my total. And then when I look at 60, my row total times my column total divided by that. When I look at 120, I get 290. A lot of room for error here just because you're just typing in so many different things. So if you're getting the wrong answer anywhere, just always double check your work along the way. And just say, okay, E's, they're all greater than 5, so we're good to keep going. And so O minus E. And then squared. Drag it down. Divided by E. All right, so our test statistic is equal to the sum of this column. And so our test statistic here is 0.5420, right? So our chi-squared test is 0.5420, the way that it rounds. And we can get our p-value, our degrees of freedom. We have a 2 by 2, so that's going to be 1 again. So our p-value is going to be chi-squared, squared dist. So we got 0.54. And the less you round, the more exact your answers are going to be. And so we end up getting a p-value here of 0.462. So our p-value is 0.462. How does that compare to our alpha of oops, sorry, I'm so used to it being 5. It's 10 this time, 0.10. So 4 is greater than 1, so it's greater than. So we do not reject the null, which basically says we cannot conclude that there is a relationship between race and social media preference. And that is how we can do, an independence test. And that's it written out for you. And go ahead and give these 2 problems a try. Press play when you're ready to see the solution. And there you go. And that concludes 12.2.